Hi, we had a question about this clicker question here. And so in the previous example, we had gone through and solved for the electric field at point A, a distance y, in between two charges, a negative and a positive. This is what we call an electric dipole. And we got an equation like this here. Our book does a similar calculation. And then one thing that we like to do is, like in this clicker question, we say, okay, so these charges are here. How does the field at A depend when y is much, much bigger than A? Which is generally how we almost always experience dipoles, because usually we're really far away, compared to the distance between the dipoles. Okay, and so what we want to do is find out, how does that depend on our distance y? And so what we do here is, here's our equation, and so we're saying that assuming that y is much, much bigger than A, okay, so what we do then, let me get my eraser here. That's a little. So we go through and we say that it's much, much bigger than A. And so what it means is, in this denominator here, if y is much, much bigger than A, we can just literally just forget about A. And so we get an electric field that's negative 2, our k constant, q times the distance A. And then in here, if we get rid of that, we have, y squared to the 3/2 power. And so if we clean that up a little bit, okay, it looks like this here, where so y squared to the 3/2 goes as y to the 3rd power. And so kind of what we're saying here is, if you can just sort of imagine, is we're imagining that the positive and the negative are like really, really tiny. So we're really far away from them. And so over here, we're at some distance y. And by this question, we're asking, basically, how does our problem depend on the distance? And if you look here, the top parts there are all parts that, are sort of things that are constant in the problem. Our k constant, the 2, the q, the a, all that kind of stuff. And so what that means is that our electric field here, which I would go back to here, so this, just to be clear, this is the electric field in the x direction. And so this electric field in the x direction, we can say that it's proportional to 1 over y cubed. And that's what that question is asking for, right? And so we know in Coulomb's law, right, in our Coulomb's law, if you just have one point charge, when we write that out, okay, so kq over r squared, where r is this distance, it goes as distance squared. So with a dipole, all right, it actually goes as distance cubed. So the electric field gets weaker faster as you pull away from it here. And the reason is because it's not just a single point charge, it's two, right, that essentially kind of cancel out. And in real life, what happens is, these positives and negatives in most cases completely cancel out. And so basically it goes with distance differently than Coulomb's law. And that's what we're trying to get at here. All right, hope this helps.